Okay. We have here our so last meeting we have discussed we have introduced the IAS computer. No, we have described ENIAC. ENIAC is the electronic version, is the nearest electronic version of the AI analytical engine. Okay, and we have described it as we have compared it against the analytical engine. Okay, so here's our comparison. Okay, ito. Do you follow? So there's a very important concept that was introduced in ENIAC. No? Remember, this is 1946, no? Right after the war. It's called the accumulator. No? ENIAC has 20 accumulators. Okay. Uh, what is an accumulator? It's actually a register like ingress and egress, but it has no distinction whether it is input for or output, used for input or output. No? It can be used for both, which means you can load an accumulator, you can also store an accumulator. Do you follow? Okay, I will retract everything, okay? I will retract everything, all assignments. No? So this is the important concept in ENIAC, the accumulator. No? Okay, it was never sold. No, it was only used for for the Moore School of Pennsylvania. No? And there were 6 lady programmers. No? It was also a decimal computer. And can you see if you look at the Wikipedia page, you will see that ENIAC was a very large computer. No? It composes a room, a whole room, a whole office. No? And then the next computer is the IAS machine. Okay. Now, this was invented by John von Neumann, no? From Princeton College, the same university that uh, Alan Turing came, where Alan Turing came from. No? Okay, this is called the stored program concept. Okay, do you follow? So we have identified what, or we have described what a stored program concept is, right? Okay, so the main difference between IAS and its predecessor, which is ENIAC, direct predecessor, is that ENIAC stores the programs on a separate device. Do you follow? No, separate device yung kanyang uh, on the input device, because computers during those days are connected to a punch card reader. They follow being the input device, and the program runs on the punch card, and the variables involved in the program are stored in memory. So it is not stored program, because when we say stored program, both the program, the commands, and the variables should be in main memory. So the idea behind is before programs are executed, they are loaded from the input into memory, okay, before they're executed one by one. In the past, no, before the AIS, programs are loaded command per command from a card reader. So the card reader is very slow. Do you follow? So the execution of the programs will tend to be very slow also. Remember that the execution repeats at its instruction. So the repetition of the program will make it inefficient. They follow? So the solution that John von Neumann presented was to load the program first, the whole program into memory, before fetching them into the CPU one by one. They follow? Okay. So aside from that, no, it is a binary computer. Okay, floating point. It uses floating point arithmetic. We'll show you that, no. But in the future sessions, we will describe what floating point binary representation is. And aside from that, it split the main control, no. The main control is split into 2 components. In the past, there's only one CPU. Do you follow? In the design of von Neumann, no, he separated the ALU from the control unit. So the ALU will do the operations for arithmetic logic unit. Okay, and the control unit will do the operations for load and store. Do you follow? Yung memory data transfer. Okay, it has one accumulator register. Remember that the ENIAC has 20. Do you follow? Accumulators. But the IAS only has one accumulator and one multiplier quotient register. Now, the combination between the accumulator and the multiplier quotient register is like the ingress and egress. Do you follow? Because when you multiply, okay, the first multiplicand is in the accumulator and the multiplier is in the MQ. Do you follow? Okay. When you divide, okay, the accumulator is in the dividend is in the accumulator and the quotient is in the MQ. Okay, the result, no? Okay. And then it has other general purpose registers, no? It has a memory address register, a memory data register, an instruction register, and a program counter. Why do we need a memory address register? The memory address register stores the address during a transfer, no? When you do a load or when you do a store, no? It stores the address. When you say load from an address, so the address is stored in the memory address register, not in the accumulator. Now, when you load or transfer into memory, no, you involve an address and a value. The value of the variable to be transferred into or from memory is stored in the data register, MDR. So these are new jargons, no? Do you follow? Do you follow? Because in the past, we only have ingress and egress, no? Sometimes, no, the value that is loaded from memory is not data. It's an instruction. So when the value that is loaded into the CPU is an instruction, it's not stored in the data register. They follow it's stored to a separate register called the buffer register, instruction buffer register, or short for instruction register. They follow? And there's another register called the program counter. Okay, and we have a diagram. Oh, we have a diagram for the IAS. There it is. I'm sorry, I'll have to load this in our site, okay? Kailangan ko siguro itong i-load sa ating site, okay? Just copy this for the moment, so you will have a reference. Okay. I should have loaded this, no? Anyway, I'll load this later, no? So this is how pwede ba natin yan, no? Oh, can we still enlarge this? Can you see this? Can you see the figure? Do you follow? No. I should have loaded this, okay? I'm sorry for that, no? I'll load this to our regular site, okay? This is the structure, a diagram explaining the structure of the IAS computer. Do you follow? Okay. So we have the arithmetic logic unit, okay, and we have the control unit. Okay. The CPU now is split into two. We have an arithmetic logic unit and a control unit. Okay. So in the past, we have ingress and egress. Do you follow? Okay. Now we have AC, the accumulator, which is used both for input and output, which means when we transfer data from main memory, it goes to the it can go to the AC, and the AC can go to the main memory. Okay, MQ is the multiplier quotient. Do you follow? It stores the multiplier kasi multiplicand yung AC and the quotient during division. Do you follow? Do you get my point? This is the arithmetic logic unit. Later in the future, we are going to study a circuit, no? When we study an actual circuit, no? Involving an arithmetic logic unit. Okay? Do you follow? Now we have a memory buffer register. Or this is the memory data register. Do you follow? Sometimes it's called buffer, sometimes it's called data. Nawala dito ang data register, right? Actually, this is the memory data register. No? It's also called the memory buffer register. Okay. Now, when you load data from memory, it goes first to the memory buffer register. Do you follow? Right away, it goes to the memory buffer register. Now, when you load data, you will specify where in memory is it going to come from, right? Okay, load 001. 001 is the address in memory, which will be the source of the data transfer. Do you follow? Okay, so the value will be stored in the MBR. The 001 address will be stored in the MAR, memory address register. This is now our store or our main memory. Do you follow? Now take note, there's a connection between the main memory and the MBR. Okay? Because sometimes, no, when the value that is loaded from main memory is instruction, the MBR is transferred to the instruction buffer register and later to the instruction register. Actually, you can look at this as a register only, no? An instruction register. Okay, this is called a pipeline. The simple design is just one register, no? They follow, which means the instruction goes into the instruction register. The instruction register contains the opcode. Take note, okay? We have opcodes. Let's look at that, no? The IAS. Okay, because we have opcodes, no? For every operation of the IAS. They follow? So the opcode goes into the IR, into the IR before it's reconfigured in the control circuit to do a command, okay, to all the other components to do what they need to do. I hope we can have, I have a circuit like this. Now, I hope I can explain it, but maybe later, no, in our future sessions, because this is a complicated circuit. No? I used to teach this in my other class. No? It's called logic circuits. No? But it requires physics and electronics. No? So medyo mahirap siya. But anyway, I'll try to explain it as simply as I can. No? What this does, the control unit. But the control unit, what the control unit does is tell everybody what to do. Okay, what will the PC do? What will the AC do? What will the MQ do? What will the memory do? And so on and so forth. No? So this sends control signals to tell all the corresponding circuits what they need to do during the next step. Okay, this is the control unit. And this is the arithmetic logic unit. Okay, do you follow? What the arithmetic logic unit does is do plus, minus, divide, multiply, exponentiation, and so on and so forth. It also does, no? The documentation tells us that the ALU also does multiplication and division. Okay? Do you follow? So I might have to ano na lang edit our ano para I may not forget, no? Okay. After this, no? Let me add source. Okay. Okay. You follow? And then the appearance, we just set this to open. We're lucky we can still edit Dagler now because sometimes Dagler becomes very slow. Maybe it's also my connection no? That makes it slow. And yesterday I was not able to edit no contents of our Dagler class online impromptu because Dagler hung. We'll transfer this before no after Inyak. Okay. Dito na lang. Dito. Okay. So there it is, no? The diagram Okay, that's what we have there. The diagram for the no. So that's the control unit. So any questions so far? No? Any questions? So this is the diagram for the IAS computer by John von Neumann. Remember 1946 ito, no? This is 1946. This is about the same time that John and Mockley were also developing their own. Kasi ang ENIAC was 1946 was produced, no? They were developing a second version called EDVAC, no? But EDVAC is a stored program computer. It's also based on the IAS. Okay? Do you follow? In fact, it was said that von Neumann has a part in the development of EDVAC as a consultant. Diba? But anyway, I'm sorry. That's the diagram. What's the actual machine? How does the actual machine look like? This is the actual IAS that was developed in Princeton College. Do you follow? No? Do you follow? So what are these? These are cylinders. 1, 2, 3. I'm not sure if these are the registers, no? But this may not be the registers. There are too many of them. Okay? Do you follow? Ito yung actual AES. Now let's look at the actual source, no? Ito yung actual source from the uh, Smithsonian Institute. I'm not sure if there's an actual machine there. Okay? Or maybe just a picture of the machine. Do you follow? Okay? Do you follow? Okay, ito yun. Wherever whatever the no, it comes with a user stand, no, floor where made of vinyl. Okay, so there it is, no. It's much smaller than its predecessor, which is ENIAC. Okay, they follow. Okay. Now, before we proceed, there's a part here, no, involving the okay derivatives of the IAS computer. Before we go into programming, no, let's look at this, no. This is from Wikipedia. What are the derivatives? Which means what were the computers that were invented after the IAS machine? Okay, it's like the IBM PC, no. It was copied several times, no. Diba? If you have an IBM PC, you don't have an original IBM PC anymore, no? Because IBM stopped making computers, no. They all come from the computers we have now are all IBM PC derivatives. Okay, so Advidac, this is ano, and then let us just mention the important ones. No? IBM 701. This is the first IBM mainframe. This is 1952. Okay, 1952. No, it was the first commercial IBM mainframe uh, uh, assembled by IBM after the IAS design. Okay, there was ILIAC. No, ILIAC was never sold by a university in Japan, no, and Illinois. So ILIAC, this is also a popular version. No? Okay. EDVAC. Now you may ask why was EDVAC not here? Bakit wala yung EDVAC? Because EDVAC was released at the same time with the IAS. Okay? Na-release siya at the same time, 1951. And it was also developed at the same time with the IAS. But remember that John von Neumann is a consultant to EDVAC. Okay? There was John Yap, okay, by the Remington Rand Corporation. What's the new Rand Corporation? Remington Rand, no? The makers of Univac, okay, competing against Mockley and Prosper Eckert, okay, because Remington Rand later evolved into DEC, no, nagiging PDP sila, and they began to compete with IBM, okay. Univac 1 was also a derivative, no, a later derivative of IAS. It's called Janyak, no. after the name John von Neumann. No? JANYAC means John von Neumann Numerical Integrator and Automatic Computer. No? Okay, strange name. Okay, there was celiac, no, in Australia. Okay, these are the direct derivatives. No? EDVAC was not listed here, but EDVAC should be one of the first derivatives of IAS machines because it was developed together with the IAS. No, they were developed at the same time. Okay, any questions so far? IBM 701, no? The derivative of ano? It's smaller, but it's a mainframe. These are not keyboards, okay? These are just switches, toggle switches. Okay? Ayun yung likod niya. It's a vacuum tube computer. IBM 701 was commercially produced. It was bought 19 times, no, in the US. These are the 701 customers, okay? It was used by IBM itself, University of California, Lockheed Aircraft, no? Most of the aircraft companies. So the first few corporations or customers of IBM, especially with their IBM 701, were mga airline companies, United Aircraft, North American, and later they developed no an airline reservation system on the IBM 701 and 706 series. It was the first, no, one of the first network computers, no. So pwede ka na, during those days you can now reserve online, but the connection is used through telephone lines. No? Telephone lines. There was no internet yet. Okay. So the IAS is one of the milestones, no, in computing history. Why? Because all computers since then were based on the IAS design. Even until now, no, the laptop or the desktop you are using is a stored program computer. Do you follow? It's a stored program computer. Programs are stored in memory before they're executed. I hope you understand that, no? Simple, the idea is simple, no? The stored program means programs are loaded from the input device or the storage device into memory before they're executed. Okay? Any questions so far? Which brings us to our, programming assignment. Okay? Uh, this is just a repetition, no? Anyway, we'll write the first four numbers. No loop ito, no? Without loop. The version for the IAS, we'll write the Fahrenheit, a centigrade to Fahrenheit, and you will write the average of the first three numbers with loop this time, no? Using, hindi na lang Google Sheet, no? Okay, let me edit this. In the past, we were using Google Sheets because they can directly be edited. But this time, no? Anyway, all Ateneo students will have Office 365. They follow? So if you log into Microsoft using your, you can now, if you log in with your, Google, no? And then in Microsoft, you can also, you can, you can make use of your Office 365 using the same. You follow? I'm sorry, I have to edit this, no? Okay. So this is your assignment, no? You are going to make equivalents, okay, of the sum of the first four numbers the Fahrenheit to centigrade, and the computation of the average, no? This time using a loop, okay? Anyway, let me have the sample, no? The sample worksheets. You can download, no? The sample. These are sample IAS programs. Let us edit this. It will be clear, no? Okay. So fourth factorial without a loop, and we will do it with a loop, no? Anyway, you can compare this at the same time, no? With your, no? With your IAS, no? Okay. Do you follow? Okay. So anyway, let's download the, no? The worksheet. Where's that? Medyo mahaba itong section na to, no? The computing history is a long, ano, especially with the addition of, ano. Meron na pala. Okay. This is the fourth factorial program. Do you follow? Do you get my point? Let us compare this with our fourth factorial from the analytical engine. Okay. I hope I can show this to you at the same time. Tingnan ko, no? Excuse me a while, no? Ano yung klase ko? Okay. I'm sorry for the disturbance, no? I have a phone call which I have to. Okay. So this is the, no, and let me copy our fourth factorial from the IAS. Lipat natin ito. Dito. Dito. Okay? You follow? No? And then, yeah. Ito yung load, no? Same thing. Do you follow? Do you follow? Okay, they're almost the same, right? Yeah, they resemble one another, and it looks like the IAS program is much shorter. Do you follow? Okay. Now, word address tayo, no? This is our command address. This is address 0, this is address 1, 2, 3, 4, this is address 5. Okay, do you follow? Do you follow?
Yes, sir.
So
Sir.
address 5, we have 40 bits. This is 20 bits. The left instruction is 20 bits. The right instruction is 20 bits. Okay? 2020 sila. Do you follow? This is how it looks like. No, it's because computer was expensive, no, and they need to have to be able to the Van Neumann needed to be able to process big numbers. So if a number is stored, no, it's stored as one whole number. Ito, do you follow? As a 40-bit number. Do you follow? Do you follow? Now, unfortunately, no, the IAS has missed a very important instruction. It doesn't have an assignment statement. Do you follow? What's an assignment statement? Anyone? Di ba sa ano? Sa C++, you say C equals 5, right? X equals 10. What do you mean when you say C equals 5? When you say C equals 5, C will have a value of 5. The value variable C, unlike in the ano, no, in the card, or rather in the in in the analytical engine, you say N0004, which means we assign a value of 4 to memory 0. When you say N0011, there's an assignment statement in the analytical engine. Do you follow?
Yes, sir.
N is the assignment statement. But in the the IIS, there's no assignment statement. Why is that? Because there was no keyboard yet. Okay? Do you follow? And your program is loaded from a deck of cards. So you arrange your cards such that you will have your variables, card variables, no? And you will have your operation variables. What do we mean by variable cards and operation cards? Do you follow? The operation cards contain commands. The variable cards contain the numbers. Do you follow? Usually in a program, no, the variables come before the instructions. Okay? Remember, this is a deck of cards in series loaded into memory. Do you follow? Do you follow? Itong 5L saka 5R, hindi ko na lang nilagay dito, no? Kasi magulo siya tingnan. Dapat ito kasi dito, this should be here. Do you follow? Okay? I didn't do that because it looks complicated because we are going to trace linearly. Do you follow? Linearly. Now that's the main problem with the IAS, you know, because it's not linear. It's not vertical. It also is horizontal, right? Unlike the analytical engine, programs are vertical from the first to the last. Ito we have a left and a right. Okay? Nowadays we don't do that anymore. So N00, we arrange our cards. Now there's a jump. In the first command is a jump. Do you follow? The first command is always a jump, even in the IBM PC, no? Actual commands runs a jump which points to the first instruction. Why? If we don't have a jump here, the CPU will process this as instructions, right? But these are not instructions. 4, 1, and 1 are not instructions. Do you follow? These are data. These are variables. Do you follow? You get my point? So we have a jump. Okay? Do you follow, everyone? You know
Yes,
what
sir.
jump? So what kind of jump is this? Jump 5, 0 to 19, which means we are going to jump to address 5. To address 5, okay? But where in 5? Because we have two instructions in 5. We have the left or the right. So when we say jump 5, 0 to 19, we mean jump to the left. Okay? Do you follow? So the first command is load M1. Okay? Do you follow? And now, to the right, we have the accumulator. Hindi na natin ilagay ang MQ, no? Because MQ is hidden. It's only the CPU which uses it. Okay? Automatic na 'yon. Do you follow? During division and subtraction. Load M1. Okay, what do we mean by load M1? M1, what is M1 here? 4. Okay, take note, no? This is also M1 because we are used to saying variables, no? Horizontally. This is M2. This is M3. M4, which which will store our result is here. Vertically, this is also M1, M2, M3, M4 because this is stored program. Okay, remember that the commands and the variables are on the same device. Do you follow now?
Yes,
No?
sir.
Stored program, so that the command and the variables are on the same device. Unlike in the Jacquard, rather in the analytical engine, the commands are on the Jacquard loom, the variables are in memory. Okay? Do you see the difference? No? Klaro dapat yung stored program concept. Do you follow?
Yes, sir.
So the first multiplier being 4 is M1. Okay? The decrement being 1 is M2. Okay? And the next, okay, the next partial product is M3. Do you follow? Do you follow? We say load M1. What do we mean by this? The accumulator becomes 4. Okay? This is the accumulator. Do you follow? When we say
Yes,
LCM
sir.
2, we mean ingress 1 becomes 4. Right? Di ba? Halos pareho lang sila. Di ba? Kaya lang dito we're saying load M1. Isn't it? Di ba? Right? So M1, the accumulator becomes 4. And then we say store M4, which means whatever the accumulator is will be stored to M4 because 4 is our first partial product. Do you follow? Remember, no? This is the result. 4 will store our result. Do you follow? Do you follow? Okay? Okay. So, and then we say sub M2. What do we mean by sub M2? What will be subtracted from the accumulator? All operations involve the accumulator. Sub M2 means, okay, AC receives, let me just, let me install an, remarks here, comment. Okay. Anong ibig sabihin ng load M1? AC receives M of 1. You follow?
Yes, sir.
That's what it means. Okay. When you say M4, it means that M of 4 receives AC. Okay? Do you follow?
Yes, sir.
Okay. What do you mean when we say sub M2? This is called the micro instruction, no? Micro instruction. Okay. We just assign it as a comment here. What do we mean by sub M2? We mean AC receives AC minus M of 2. Okay. Do you follow? No?
Yes, sir.
So what do we mean by, what is M of 2? It is currently 1. Okay. So AC receives 3. Do you follow? AC becomes 3. Is it clear? Bakit siya
Yes,
naging
sir.
3? Because it's 4 minus 1. And then we say store M1. What does store M1 mean? M1, M of 1 receives AC. Do you follow? So
Yes,
where's M
sir.
of 1? This is M of 1. Okay? M of 1. So now M of 1 becomes 3. Previously it was 4. Now it becomes 3. So we can say that M of 1 here is the next multiplier. Do you follow? Do you follow? The next
Yes,
multiplier.
sir.
Okay, so it's very clear, no? So I hope you can understand this. The main difference being the stored program concept. Okay? Mul M4. What do we mean by this? AC receives AC AC times M of 4. Do you follow? Do you follow?
Yes,
So now
sir.
you see the concept of the accumulator. Without the accumulator, it's very difficult to do a sub, no? That's why it's easier because we only have one instruction. When we say sub, we are going to subtract something from the accumulator. Do you follow? So the concept of the accumulator will simplify the programming. Do you get my point? I'd like you to understand that because later we will have a lot of accumulators, no? Even if you go into C++, C Sharp, JavaScript, you will use accumulators. Do you follow?
Yes, sir.
Okay, so take note the importance of accumulator. That's why ENIAC became very popular because the legacy of ENIAC is accumulation. It was first invented in ENIAC. Do you follow? Where is the accumulator first invented? In ENIAC, not in the IAS. So you see there was an evolution, no? So the evolution is clear. From the analytical engine, there was the invention of the accumulator. From the invention of the accumulator, there's the invention of the stored program concept. Okay? Diba? That's what we wanted to know. Okay? So, what is M4? M of 4 is 4. M of 3 is, the accumulator is 3. Okay? Diba 3? 3 yung accumulator. It was 4 plus 1. So, AC receives 3 times 4. So, 3 times 4 becomes 12. Okay? And we say store M4. What do we mean by this? M of 4, which is our next partial product, receives AC. Okay? You must understand, no? This because later we are also going to trace even in your succeeding subjects, when you study digital design and then computer organization, programs are written like this. Okay? Programs are written like this, no? Store M4, which means M4 receives the accumulator, so the accumulator at M4 now becomes 12. Do you follow? No? Okay. Shall we proceed? No?
Yes, sir.
So, no, the accumulator, no? The concept from ENIAC. Please remember, no? Ay, sorry. Okay. Load M1. What do you mean by load M1? Anybody? AC receives M of 1. Ayun, no?
1.
Kopyahin na lang natin ito. AC receives M of 1. So, what is the accumulator? It's M of 1. This is M of 1. Okay? M of 1 is 3. 3 is our next multiplier. Okay? Now, we compute the next multiplier. How do we do that? We sub M2. Okay? What do we mean by this? AC receives AC minus M2. Ayan, pabalik. It just repeats itself. So now this becomes 3 times minus 1. So AC becomes 2. Okay? And we store M1. So meron naman, we have a store M1 here. Okay? We just erase the ano na lang, no? Erase na natin ito. We don't need that anymore. Okay? You follow? Okay. So this is a repetition of compute the next partial product and compute the next multiplier. Right? Store M1. This is M1 receives AC. Do you follow? So M1 now becomes 2. From 3, it's now 2, which means that the next multiplier will become 2. Do you follow? Do we have a halt? Meron ba tayong halt? I'm sorry, meron ba tayong halt? I'm not sure, no? Wala siyang sinabing halt. Okay? We don't have a halt, unfortunately, no? Okay? Now, a halt can be jumped to the same address, okay? Do you follow? If there's no halt, we do a jump to the same address, okay? Do you follow?
Yes, sir.
I'll show you that, no? Anyway, no? How to jump to the same address, okay? So now we have load M4. So M4 receives AC. So nag-erase ko na lang, no? But it's okay. M4 receives AC. So now M4, okay. What's the value of AC? AC is currently 12, no? No, load M4, I'm wrong. AC receives M4, right? Load M4 man. Why do we have a load M4? the partial product, no? AC receives M of 4. Why do we have an M of 4? 12, no? So this is not repetitive anyway, no? Say AC receives M4. So AC becomes 12 because M4 is now 12, no? They follow? Oh, that's why we have to load AC. Because here we don't have to load AC because it was already loaded with M1, which is 4. Do you follow? Okay. I hope you follow, no? You ask a question if you don't know. Do you have a chat? Okay. So AC receives M4. So now AC becomes 12. And then we mul M1. Okay. So receives AC receives AC times M of 1. Okay. What is M of 1? Our next multiplier, which is 2. So we'll have 2. Okay, 12 times 4, it becomes 24. And then we store M4. What do we mean by this? We say M of 4 receives AC. So this repeats. We just copy this. So M of 4 is 24. Okay, so we have computed the next partial product. The next thing to do is to what? Compute the next multiplier. Okay, the current multiplier is 2. So we load M1. So AC receives M of 1. This one. We follow. And then we sub M2. Do we have a sub M2? Yes. AC receives AC minus M2. That's how it is, no? So this is equivalent to 2 minus 1, so 1. Okay. And we store M1. M1 receives AC. Do we have that? Yes. We just copy this here. M1 receives AC. So eventually M1 here becomes 1. This is M1, right? This is our next multiplier. So we load M4. AC receives M4. This is now a repetition. Okay. They follow. And then so AC is now 24. We mul M1. Okay, so AC receives AC times M of 1. This one, right? I hope you follow, no? So it's equivalent to 24 times 1. This is 24. Okay? Okay, do you follow? And then we say store M4. So M4 receives AC because our result is an M of 4. Do you follow? Okay? Do you follow?
Yes, sir.
Okay, and this is our 14. This is 14. We'll just say jump 14, 0 to 9. Okay? Okay? Jump to itself. Okay? Which means we will
Yes,
now
sir.
halt. This is our halt. Okay? Any questions so far? Questions? This is 14R, 14L. Okay? I'll post this. I'll update na, no? Kasi walang ganito, no? Di follow?
Sir, if
Yes?
di ba dun sa activity, sir, may loop po, sir, paano mag...
Yeah, we will discuss that later, no? Because we have a jump plus, no? May konting problema lang tayo sa jump plus, no? May konting problema tayo sa jump plus, no? You want to discuss that now? Before we proceed to, ano? Shall we just discuss the others? Or can you just study this yourself? So, the others like Fahrenheit to Celsius. Ito. And this is meters to feet. Okay? Because we have a jump plus. No? Anyway, we have a jump plus instruction. this is a very close look alike of the CF and CB, which we discussed. Okay? Kaya lang, the problem with CF is it will not work with 1 minus 1, right? Kasi 0. It will work with 1 minus 1. But this will not work with 1 minus 1. Do you follow? Because 1 minus 1 is still a 0. This will work with 1 minus 2. Because when 1 minus 2, it becomes negative 1. Right? Jump plus will no longer execute. Do you follow?
Yes, sir.
Okay? Ito lang, this is the main difference between CF and jump plus. Jump plus will work with 1 minus 0. Right? No, sorry. CF will work with 1 minus 0. It will start working with 1 minus 0. But jump plus will not work with 1 minus 0 because 1 minus 0, 1 minus 1. 1 minus 1 is still a 0. Right? Diba? So we have to be a little bit careful. Okay? But before we do that, no, let us introduce the IAS programs from Fahrenheit to Celsius. Mabilis lang naman ito eh. Okay? Do you follow? Madali lang naman ito eh. Okay? Do you follow? So this is it. No? We jump 60 to 19. Jump to the left. We are converting 132. Okay? From Fahrenheit to Celsius. Do you follow? No? So first we load M1. So we say AC receives M of 1. Do you follow? So, nandito naman siya, no? AC receives 32. So, 132. Hindi na pala kailangan, no? But we'll just write the micro instruction, no? Sub M2, we say AC receives AC minus M of 2. Okay, eventually we say AC minus 32. So, AC becomes 100. And we say mul M3. M3 is 5. Okay, we say AC receives AC times M of 3. M3 ba? Yes. They follow? So the equivalent is AC equals AC times 5. We have 500. And we have div M4. They follow? So we say this is equivalent to AC receives AC divided by M4. Okay. We are actually dividing it by 9. No? And we store M5. Okay. M5, which is the final result, receives AC. Okay. And we'll have 8R. This 8R. To do a halt, what do? We say jump. Okay. This is 8, 22, 39. Do you follow? This is our halt. Okay? Do you follow?
Yes, sir.
So very simple, no? Okay, so stored program tayo ngayon. So our thinking is slightly different. Okay? So ito yon. Anyway. Okay? So jump. This is AC receives M of 1. Okay? And then we have AC receives AC times M of 2. Okay? And then we have M of 3 receives AC. Follow the result is NM3. This is the result, no? The self-explanatory. And then we'll have a halt at 5R. Okay, we have halt. So you jump 5, 5, 22 to 39. Okay, this is our halt. Okay, we'll have to do that, no? Kasi ganyan. In other documentations, they do a halt by doing a endless loop there. Ganun lang talaga sila. Because we don't have a halt instruction. Okay? Okay, any questions so far?
Paano yung loop?
What's this? Sandali lang ha. Yes? Sandali lang, I've hidden my Uh, I don't know who's asking the question. Yes, any questions? Loop na tayo. Okay,
Yes.
we'll do a loop. So, we'll have to copy this. No? Kailangan natin ito. Kasi ang problema natin dito ngayon, we need a 3. Kasi I think we need a third, another one. No? Maybe a 3 or a 5. No, we'll just adjust that. Okay. I haven't done this before. No, I'm going to do this impromptu. No. So anyway, we'll need another variable because the difference between jump plus and CF. Okay. Let me have my Excel. A new. Okay. We may have to use until M5. No? Bold natin ito. Why doesn't it go bold? Yeah, it goes bold. And then we'll have to do this. I think we need an M5. No? Okay. And then we'll copy this. I think we need a 3. Okay. Kasi we'll just put a 3, no? Ano, the 3 will put in here. Our result will be in M5. Ito yung result, no? Okay. Do you follow? So this is a jump 6. Jump 602, ano? Do you follow? This is 6L. Let's change the orientation. Okay. Sorry, mamaya na lang natin save, no? So the first is AC receives M1. Kasi 4 ito eh. Dapat 3 ito. Okay. This is our decrement. What's the use of this? This is our multiplier, no? This is our multiplier. Next multiplier. This is our bakit hindi na ginamit ang M3, no? Was M3 used here? We haven't used M3 pala. Okay, so maybe we can just use M3 is unused, no? Anyway, we leave it there yet. The result is an M5. Next multiplier, M5. This is also the partial product. PP slash result. Okay, PP stands for partial product. Okay, do you follow? This is our loop counter. Okay, how many multiplications do we need? We need, kasi we start with 3. Kasi pag 3 minus this and that, our jump plus will work. This will be our decrement. Okay, do you follow? Sorry, we can save, no? So 6L will have load M1. Okay, so we'll have AC receives M1. So what's the value of AC? Bakit ganito? Okay. AC becomes 4. Okay, do you follow? Store M4. M4 pa ba tayo? M5 na tayo. 6R. store M of 5. Because M of 5 is our next partial product. So we copy this. Kasi ano eh, why don't we just use this as our ano, kasi M3 is not used. We'll remove this, no? Para di tayo mahirapan. Okay. This will be our loop counter. We change this a little bit, no? Kasi mas madali pala kung walang ano. This will be our PP. And then result. Okay. So that this will be just we store M4. No? Let's put it the values here. We'll have 4. Loop counter is 3. Okay. And this is our partial product. Okay. This M2 is 1, M3 is 3, and M4 is vacant. So we may not need an M5. Okay. Store M4. So we'll say M4 receives AC. Kaya pala yun, that's why there's a vacant ano, in the original program. Okay. There's a vacant in the original program because yeah, it is easier to convert into a loop. Okay. M4 receives AC. So now M4 is 4. Okay. Do you follow? Do you follow? Okay.
Yes, sir.
And then we will have a sub M2. We'll compute the next. This is now 7L. Okay. Let me just change the, kasi naka-ano siya. I'll have to change it that way. No? So that I have to do, I don't have to do it every time. So sub M2, what will we have? I'll just copy it from the previous code. I'm copying it from the previous code, no? By the way, if you're wondering, I'm typing fast. Sub M2, AC receives. So what will be AC? Contents. Anong contents nito? Load M1. So anyway, we know what is it. What is sub M2? We know that this is M4 4 minus 1. Okay, 4 minus 1. Okay, AC becomes on. I'm sorry. Let's change the now format. Ang hirap ng format nito. Is date. 0 decimal places lang, no? Okay. This is what? This is 4 minus 1. Okay. So AC is 4. As AC is 3. Do you follow? Okay. 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 And then we say store M1 because M1 is our next multiplier. Okay. This is 7R. Store M1. So M1 receives AC. That's what it does. Do you follow? I'm still copying, no? Sorry. I'm still copying, no? Bakit hindi na gano'n, no? It didn't follow my formatting. But anyway, M1 is now 3. Okay? Okay, when are we going to, when are we going to stop? Can we do an 8L? And we have to do a jump, no? No. If we are going to load an M1, M1 becomes, AC becomes 3. Hindi na pwede doon. Okay? Because yeah. Kasi we'll have to check for for a jump plus. If it's positive, the result AC is still positive, right? So we do a jump plus to a previous command. Okay? So we should compute the next, we should compute the, no, not yet, no? Mali ito, no? There's something wrong with this, okay? We should do, a mole, okay? Okay. Okay? Dapat hindi M1 yung ating load. We load M2 and we mole M1. Okay? Because M2 is 1, okay? And M1 is 4, so we'll have 4 times 1. Okay, is that correct? Tama ba tayo? And then, okay, can we do this here, no? Like this? Let's change this a bit, no? We load M3 will be incrementing, no? We load M3. M3. And then okay. I'm thinking now. If you load M4, M4 is still blank. Okay. Okay. Kasi kung gamitin natin, if you'll make this a 4. If you'll make this a 4, no? So this is a 4. Okay. We might as well use M1 as our ano. Okay, let me do that, no? Ang M1 ang gagawin nating final answer, okay? Load M4. And then, what do we multiply it with? Mole M3. M3. Okay, do you follow? Do you follow? So, what will be AC? AC. I'm sorry, no? AC will become 4 and we multiply with M3. The next multiplier is a 1. Okay. So, mole M3, so we have the contents will be 4 times 1. Okay. So this becomes 4. Okay. And then we store M1. Store M1. Okay. So M1 becomes a 4. Do you follow? No? And then we are going to compute the next multiplier. So yeah. Dapat this should be a 4 also. No? So why don't we just do a load? No? There's another way to do this. Because probably there's another way to do this. No? 4 ito. Okay, so that we can say load M3, M of 3. We compute the next multiplier, okay? Load M3, so let's erase this first. It becomes of AC. AC receives 4. And then we say sub M2. We have 4 minus 1, right? Now this becomes a 3. Do you follow? This becomes a 3. Okay. And then we say an 8R, we say jump plus. Jump plus. Where do we jump? 6, 0 to 19. Okay. Do you follow? And 9L, this is our hot. Anyway, we'll try to do that, no? Okay. Let's check. Load M1. Okay. X1. And then mul M3. It's 4 times 1. And what if we have? It's sandali ah. Sandali. Kasi yeah. If you are going to store our parcel product here as 4, so we are going to load M4. Let's copy this anyway, no? I'm running out of time. I'm sorry, no? Okay. Okay. I'm sorry, I'm running out of time. I'm going to do this offline, okay, everyone. But I hope you're getting the point, no? We are going to repeat, and then we are going to jump back if we have a plus. Otherwise, we'll have a hot. Okay. Any questions so far? We'll finish this next meeting. Anyway, I'll postpone the ano na lang because we don't have a jump yet. I'll postpone it on Wednesday. Okay. It's almost 3 o'clock. I can't finish this. Okay. I'm sorry, no? Okay.
Sir.
Everyone, I'll postpone the submission of the assignment on Wednesday. That's August 4. Okay. I'll do this offline. Okay.
Thank you, sir.
See you next meeting. Did I miss anyone? Did I miss anyone? Any latecomers? Let me call. Awing. Not there. Kanakan. Labrador. Lumapay. Placer. Sevilla. Nobody? Okay. So thanks for coming, everyone. No? See you next meeting. I'll update the assignment myself.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
See you next meeting,
Thank you,
everyone.
sir. Oh, ay sir,
Thank you,
yung
sir.
Thank you, sir.
nakasubmit, sir, pwede pa to ma-edit
Yes,
yung...
I will recall everything, no?
Okay, sir. Thank you, sir.
We will call everything today. Okay, thank you.